Welcome to the Introduction to the Food Service Industry Interactive Study Course. The North American Association of Food Equipment Manufacturers is often referred to as NAFEM. The Introduction to the Food Service Industry curriculum consists of 20 e-learning lessons. The first chapter is what you're working on right now, the overview and introduction to the course. The titles of the other chapters that you'll be studying are Distribution Channels, Food Service Facility Design, Utilities, Basic Design Considerations, Kitchen Ventilation, Basic Design Considerations, Approval and Third-Party Testing Agencies, Food Safety and Sanitation, a Process Overview of Food Production, Receiving, Storage Design and Equipment, Ingredient Preparation, Equipment Considerations, Cooking Equipment, Types, Sizes, Applications, and Specification Considerations, Bakery Operations, Equipment and Supplies, the Service Area, where food, beverages, and service come together, Front of the House Design Considerations, Effective dish room operations and equipment, cook-chill production methods, systems, and specialized equipment, specialty markets and their special equipment and supplies requirements, smallwares, new and emerging equipment and supply technology. The first thing to know about the commercial side is that all commercial segments are in business to make a profit. Customers of commercial operations have access to many meal alternatives. These operators must actively compete for food dollars and are focused on generating new and repeat business. The design process involves 9 phases. These are initial contact and proposal, feasibility study, programming, initial design and cost estimates, design development, which involves both engineering and equipment specification, bidding and awarding contracts, project construction, inspection and acceptance, and implementation and training. As one of the components of Phase 4, initial design and cost estimates, the design element usually consists of schematic drawings showing the shape of the building, various entrances, flow patterns, and location of the dining room, kitchen, and other functional areas. Equipment specification is one of the most important components of the design development process. The most important thing is to ensure the exact requirements for the equipment are clearly written. From the design consultant's perspective, the best piece of equipment is the piece that matches the specifications exactly. We need to convert the energy use of each of the appliances to a common denominator, in this case, BTUs. Here you see how 15 kilowatt hours is converted to a BTU equivalent. So it looks like the gas appliance consumes 40,000 BTUs per hour, compared to the electrical appliance's consumption of 51,180 BTUs. But we're not done yet. Next, we must consider the efficiency of the cooking equipment. If the electric unit is 80% efficient, while the gas equivalent is only 40% efficient, the net heat into the product will be 41,000 BTUs and 16,000 BTUs respectively. Cooking equipment operating efficiency is a percentage that represents the net BTU energy transferred into the product divided by the total firing rate or BTU input of that unit. All energy that isn't transferred into product is lost as waste heat radiated into the kitchen or lost up the flue stack. Welcome to Lesson 14, Front of the House Design Considerations. Our learning objectives are that at the end of this lesson, you'll be able to describe the basic space requirements, limitations, and front-of-the-house design considerations. Explain the roles lighting and color play in the overall design of a dining area. Describe the considerations for choosing the different types of dinnerware, flatware, and glassware. State the factors associated with the use of table linens and tabletop accessories. And list the furniture available and the selection process criteria. The front of the house is better known as the dining room. The dining room can be thought of as the stage where good food, personal service, and atmosphere come together to deliver a memorable dining experience. Dining room space requirements are usually based on the number of square feet per person seated, multiplied by the number of persons seated at any one time. This table provides some generally accepted space allowances per seat for the various types of food service operations. As you can see, a lunch cafeteria requires only 9 to 12 square feet per student, while a counter service restaurant requires from 18 to 20 square feet per customer. Some of the other factors that need to be considered when evaluating dining space requirements include use of service stations. Service stations can be estimated based on one small unit for every 20 seats, or a large central service station for every 50 to 60 seats. The size of tables and/or booths used. For instance, in a cafeteria, patrons are more likely to dine directly off of the trays. It's important that tables be large enough to accommodate the size and number of trays expected. Aisle space between tables and chairs needs to include a passage area, plus the area occupied by the individuals seated at the tables. Historically, the minimum passage area has been 18 inches between chairs or tables when placed 4 to 5 feet apart. However, the Americans with Disabilities Act requires 36 inches of clearance in dining area aisles for the maneuvering of wheelchairs, and that a minimum of 5% of total seating be accessible to wheelchair users. Color should be used in conjunction with the lighting scheme in order to achieve a desired atmosphere or mood. Patrons feel the psychological impact of light and color without realizing it. Light and cool colors are used to expand the sense of space. Dark and warm colors are primarily used in large rooms and tend to shrink the room and make it feel more personal. They also create a sense of intimacy. Let's begin with the identification of the common causes of foodborne illnesses. The Center for Disease Control in Atlanta has identified the following factors responsible for the bulk of reported foodborne illness: purchasing food from unsafe sources, failing to cook food adequately, holding food at improper temperatures, using contaminated equipment, and poor personal hygiene. Food safety hazards are generally identified as one of 3 types. Biological hazards are posed by living organisms that can grow on or survive on food. They include bacteria, viruses, parasites, and fungus. Chemical hazards include pesticides, food additives, preservatives, cleaning agents, and toxic trace metal. Physical hazards include foreign objects accidentally or intentionally placed in food. What can an operator do to avoid biological hazards? Although it's impossible to eliminate all harmful bacteria, significant steps can be taken to limit their spread, growth, and potential impact. For example, the development and maintenance of proper housekeeping procedures and ensuring that every piece of equipment is in a high state of cleanliness is important. Operators should select the proper detergents, sanitizers, and cleaning chemicals, as well as the proper cleaning tools and housekeeping procedures. These procedures should include what's to be cleaned, how it's to be cleaned, and how frequently it's to be cleaned. These tasks need to be done every day at a minimum. The Hazard Analysis and Critical Control Points, also known as HACCP, process has emerged as the most effective means of assuring food safety. HACCP is recognized as a systematic and proven path to food safety. HACCP is a management, control, and documentation process that must be customized and written for each food service operation. The term mise en place means get your mess in place in French. Culinary schools emphasize the importance of mise en place and teach many techniques to assist aspiring chefs how to do so. It all gets down to having sufficient quantities of all key raw ingredients and herbs ready for use. This means that everything has been cleaned, cut to size, portioned, or measured.
Flour is the most important ingredient in baked products. Flour forms the basic structure and influences the texture, taste, and nutritional value. The most commonly used flour is wheat. Wheat flour is composed of protein, starch, enzymes, fat, sugar, minerals, and moisture. Protein is one of the most critical elements found in wheat flour. The specific proteins found in wheat flour are glutenin and gliadin. These are mixed with water to form a substance known as gluten. Gluten gives dough its extensibility, elasticity, and gas-retaining properties.
Equipment and supply dealers may be responsible for the consolidated purchasing and assembly of all buyout items for a particular new installation or kitchen renovation. These buyout items can include anything from cooking equipment to refrigeration, shelving, and in some cases, dinnerware and furniture. Pressure frying can be described as a 4-stage process. Stage 1 is when the food product begins to heat in the shortening. Moisture from the food starts to vaporize and form steam around the product. This in turn retards the penetration of shortening into the product. In a short period of time, sufficient steam vapor has been trapped in the fryer above the shortening. During the second stage, a significant amount of pressure occurs. The normal operating pressure of a pressure fryer is between 5 and 12 psi. During stage 3, the natural juices of the food can no longer force their way out of the food, and the food retains up to 75% of the juices. During stage 4, pressure builds up inside the cooking pot, creating a minor turbulence in the shortening. This causes the food to gently tumble and fry evenly and thoroughly.
While rack conveyor machines start washing as the rack enters the machine and allow for dish drying on tables outside the machine, the flight-type machines are longer because they need sufficient conveyor space for loading prior to the soiled dishes entering the wash or pre-rinse chamber. They also need space for dish drying on the conveyor outside the final rinse chamber. Flight-type machines come in double, triple, and sometimes custom-built 4-tank units. Double tanks are preferred for schools, where the food is simple and variety limited.
Okay, let's first focus on the Type 1 hood categories. Remember that Type 1 hoods are used for the collection and removal of grease and smoke. There are 3 basic categories of Type 1 hoods. Non-listed hoods that have not secured approval by Underwriters Laboratory. The second category is UL-listed exhaust hoods without fire exhaust dampers. And finally, the third category includes UL-listed exhaust hoods with fire exhaust dampers. Removable extractors are typically fabricated from stainless steel and contain a series of horizontal baffles. These baffles are designed to remove grease and drain it away into a container. As the air is drawn around the baffles, typically at a rate of 1,000 to 1,200 feet per minute, the grease is thrown out of the airstream by centrifugal force. The grease then collects on the baffles and other interior surfaces of the extractor. Like baffle filters, removable extractors come in various sizes and are easily removed from the hood and cleaned by running them through a dishwasher or by soaking and rinsing them. Grease fires and flare-ups caused by open flame gas equipment are common and potentially dangerous. While proper hood design, grease extraction, and regular cleaning can minimize the chances of kitchen fires, modern fire suppression systems can serve as a critical backup. Fire suppression systems can be specified and integrated into the design of the hood systems or retrofitted into existing hoods. These systems typically rely on heat-activated spray heads to initiate a flow of fire suppression chemicals, water mist, or a combination of agents to extinguish the fire and prevent the restart. General rules for reducing replacement costs include selecting glassware with a heavy bead or roll on the lip. This provides reduced chipping. The thicker the glass, the greater the durability. A straight-sided glass is more durable than one that has curves or bulges. Flared glass is more likely to chip, crack, and break than straight glass. Most operators choose glassware from each of the following three design categories. Tumblers, which are designed without a foot or stem. Goblets, which consist of a bowl mounted on a short foot. And stemware, which is a glass bowl mounted at the top of a stem which connects the bowl and foot. While many of the ideas that we've discussed take time or money to implement, there are definitely some actions that can be taken immediately that are not cost prohibitive. Here are just a few of them. There's a tremendous amount of oil that gets processed in a food service establishment on a daily basis that can be recycled. Fryer oil, which can be turned into biodiesel, a clean-burning fuel, is probably the most obvious example. Unfortunately, significant amounts of fats, oils, and greases, sometimes referred to as fogs, often end up finding their way into the waste stream, where they play havoc on the sewer system.